Our first location is the Zapiola Ridge Abyssal Mud Wave field. It sits at a depth of over 5 kilometers, has the largest moving bed forms, which are essentially sand dunes, in the world. Now I say sand dunes, but they're actually not made of sand, they're made of mud. And it's not really dunes either, it's sort of a mysterious type of landform that is exclusive to several locations in the deep ocean. So the tallest of these abyssal mud waves are about 400 feet, which is absolutely crazy. And they are moving at an extremely slow rate, at about half a millimeter per decade, right? So they are migrating just like sand dunes in this direction. Now, what's really mysterious about these is that people really don't know how they form. The whole field is absolutely vast. So if you look at all these sonar tracks here, we have a glimpse of the size of the actual full mudwave field, which is about the size of France. Really, this whole giant area. And if you map them really carefully, which I did, I'll pull up a figure, then you'll see that their direction is sort of a vortex. So they rotate across a central point. So they're very mysterious. There are some other locations that are a little bit similar. So here in the North Atlantic, we have the Faney Drift. So these only have heights of let's say tens of meters. So our next location is the Diamantina River in Australia, which is a river that has actually a very small discharge, which means that not that much water flows through it normally. Just about 20 cubic meters per second, which is comparable to a small or medium-sized river. But as you can see, it has this really crazy braided river pattern. So there, in some cases like here, you have maybe thousands of very small parallel channels that all together move this water. And the reason that this river is so crazy is because it's one of the most variable rivers in the world. So in some cases during these flood events, it can suddenly carry about 1,000 times more water than normal. And because of this, it doesn't really incise into the landscape like most other rivers do, which means that it doesn't really form a very nice channel. It just has 1,000 very small parallel channels. So if you just look at these images, like you cannot even count how many channels there are. In some very wide parts where the width of the entire braid belt is up to 30 kilometers. Our next area is called Bahr al Tubat. It's actually a series of water bodies really close together. And what's really cool about it is that it's in the middle of the Sahara Desert. So this is really one of the world's most remote oases. So if you zoom out, then this whole area has sort of scattered water bodies. I can show you some pictures of what that looks like. So it really is like a tiny lake in the middle of the desert. That obviously there's very little rain in the desert itself, so not enough rain to sustain such a large body of water. So the water actually comes from a distant area in a wetter environment. So perhaps due north, closer to the sea, we have a region that has more rain, and the rain infiltrates into these permeable layers, which can then, because of their geometry, outcrop or expose some areas in the middle of the desert. So that's how you get this water to basically come up from the ground in the middle of the desert. Our next location is the famous Ship Rock in New Mexico, which is one of the most classic, beautiful examples of what's called a volcanic throat. So this thing is actually really huge. What I tried is I put a small box here that has the same dimensions roughly as the Empire State Building, just to give you a slight sense of how enormous this thing is. What do I mean with a volcanic throat? It's sometimes called a volcanic neck, is that it's the erosional remnant of the plumbing system of what was once an active volcano. And that includes some of these really long features, which are called radiating dikes, right? So at some point a long time ago, in this case roughly 27 million years ago, you would have an active volcano like this thing here. But since then the volcano has become inactive and the material surrounding it began to erode. So the hard igneous material that is the solidified throat, the neck of the underground material that comes up remains after all the softer stuff has eroded. And because this whole plumbing system is shaped like these sheets of magma, which are called sills if they're horizontal and dikes if they're vertical. And that leaves this beautiful throat in the middle with these radiating dikes emanating from it. So another very famous volcanic neck or volcanic throat is this place called Ball's Pyramid. And the Google Earth doesn't really have really nice 3D photogrammetry here, but it does have a cool satellite image. I'll pull up a real photograph of this place, because it's an island that is just like Ship Rock. It's extremely small in footprint and extremely steep. And the concept here is exactly the same. So this is the erosional remnant of what was once an active volcano. And if you zoom in closely, these little tiny sub-islands, they may actually be some remnants of radiating dikes in the same way that we saw those in Ship Rock. So our next area is just a really beautiful strato volcano. It's on the southern side of the Kamchatka Peninsula, and which is an extremely volcanically and tectonically active area. There was actually an 8.8 scale earthquake tsunami here just a couple weeks ago. So the reason I think this is such a cool volcano is because it very beautifully shows several features that are very common in stratovolcanoes. So obviously we have the cone, which is the mountain itself, right? That formed because of a series of lava flows that accumulate on this area. Then we have a volcanic neck collapse. In some cases, the conduit where the magma is forced upwards from the magma chamber to the surface loses pressure. And when the pressure becomes too low, gravity takes over and we get a huge hole that collapses into the volcanic neck. And that's what's shown here in this big hole. Now a third feature are these two flows, which they might look like lava flows, but they're actually lahar, so a sort of mudslide. And they're quite common in these areas where the volcanoes are active or recently active. So this volcano was active only a couple thousand years ago. And because of that, it's grown very steep and very fast, and it's relatively unstable. So because of frost weathering and other processes, a lot of this material on this very steep part of the slope just gradually slumped down into these lobes. Now the final feature that is also right next to this volcano is this lake. And this is a caldera lake. So very similar to this throat collapse, this is the collapse of not the throat of a volcano, but a deeper, larger magma body inside the magma chamber, or actually the magma chamber itself. So next is the largest confirmed impact crater in the world. It's called the Vredefort Dome, or the Vredefort impact structure. So it's about 2 billion years old, making it roughly half as old as the Earth. And it's only partially been preserved. So basically the southwestern hemisphere, so this whole portion is totally flat. So all of this has eroded, so that's not preserved. But these ridges that you see here, they are part of this very large impact crater, or it's rather an impact structure. So it's really the root system of what was once a giant impact crater. This feature, this dome feature, is very clearly visible, but there are some features that are further out, like here and towards the back, all the way up to here, that show you that this entire structure is much bigger than this inner ring, right? So we're really talking about really this sort of area. And the total diameter is estimated at more than 300 kilometers. So it really extends all the way far out into here. So just to show you a little bit better what this structure looks like geologically, I found this nice article on volcanocafe.org. And what you see is it's a series of essentially faulted blocks. So really big chunks of rock that have been broken and formed in these concentric patterns. One of the most spectacular things you can find in this area geologically is the textures of the rocks. So they are what's called an impact breccia. So these are really strong gneisses and granites, and they've essentially been completely exploded and pulverized, and all the material in between these chunks has rapidly melted to form this black glassy texture. So this is really something that is very characteristic of an impact. Now, another thing that is very characteristic of this type of impact is what's called a shatter cone. So these are types of structures that only form in relatively large meteorite impacts. So for our final area, we are going to the southern portion of Iran. What we're focused on is these blobs. So you can see a very rocky landscape with these dark colored blobs scattered across the area. And what's interesting is that if you zoom in, they have this very crazy looking colors. So there's greens, purples, pinks, all sorts of colors that are a little bit unusual in most rock types. So the reason they have these colors is because these are salts. So these are what's called salt domes. So salt is interesting because when layers of salt get buried, they will actually behave kind of like bubbles in a lava lamp. So you have a nice surface here, and you have a layer of salt. And after some moment of time, the salt will basically be like bubbles. So these bubbles, they will rise up, and they will eventually enter the higher, younger layers of the rock. Now, when this is combined with erosion, so let's say there's erosion and the formation of a new landscape, then in some cases you can have the situation where these salt domes, they form the surface. And that's exactly what we're seeing here. Obviously, salt dissolves in water. So most of the time, these superficial salt domes will dissolve in contact with the rain. But because this area is so dry, these salt domes have managed to stick around here on the surface. So this very colorful geology that you see here, that's actually what it looks like if you go there. So these are pictures that are taken in this area. And you can see that these exposed pink and green and bluish salts, they actually look like that in the field.